At the National Ignition Facility based at Lawrence Livermore Laboratory in California, scientists have made an important breakthrough in efforts to harness nuclear fusion as a practical source of energy on Earth. They're closing in on what's called ignition, achieving a fusion reaction that produces more energy than it takes in. There are two basic ways to make energy from nuclear reactions: fission and fusion. Fission is when large nuclei break apart and release energy, and is the process currently used in nuclear power stations to generate electricity. Fusion is when small nuclei, such as those of hydrogen, collide and combine to produce larger nuclei, such as those of helium. Fusion is the process by which the Sun, deep inside its core, generates the heat and light that makes life possible here on Earth. But achieving nuclear fusion requires incredibly high temperatures, many millions of degrees. A major challenge in harnessing fusion as an energy source is to contain extremely hot ionized gas, or plasma, long enough for the reactions to be self-sustaining. The new results are a step forward in that not only is the energy output close to that being fed in, but the fusion reactions themselves are providing enough heat to cause more fusion. The National Ignition Facility uses a technique known as inertial confinement, which involves firing powerful laser beams at a small source to trigger nuclear fusion. 192 beams are aimed at a tiny capsule containing deuterium and tritium, which are two different forms of hydrogen. The laser light squeezes the fuel to 100 times the density of lead and a temperature of 100 million degrees Celsius, hotter than the center of the Sun. An experiment carried out on August the 8th, 2021 yielded 1.35 million joules of energy, which was around 70% of the laser energy fed into the fuel capsule. Further experiments will now be carried out in an effort to increase the energy yield and the length of time for which the reaction is confined. Meanwhile, there are a number of other projects around the world with the same goal of making fusion a practical energy source. Most of these involve a different approach called magnetic confinement, which uses powerful magnetic fields to confine the hot plasma. But despite the recent progress, we're still some way from having fusion power plants that will be able to supply a significant part of our energy needs from this clean, safe, and abundant resource.